Today, I'm going to introduce you with the line spectra of hydrogen atom. Diagram showing the Balmer series emissions line spectrum of hydrogen atom. As discrete color lines are shown on the spectrum, it means that the emissions occurs in the visible light region. So, how to produce the line spectrum? Can the line spectrum emissions occurs at different regions? The emissions can also occur at different regions to give different series of line spectrum. For example, emissions occurs at ultraviolet region to give Lyman series. For Balmer series, emissions occur at visible light region. For Paschen, Brackett, and Pfund series, the emissions occur in infrared region. In the next slide, I'm going to introduce in details how to form the emissions line spectrum. First, hydrogen atoms are put in the discharge tube. Each hydrogen atom has one electron, as illustrated in the diagram. Initially, the electron is occupying at the ground state, n equals to 1. When energy is supplied, the electron absorbs the energy and moves to the higher energy level. At high energy level, the electron is unstable and will fall back to lower energy level by emitting photon with specific wavelength and frequency, which give the discrete lines on the emissions line spectrum. From previous slide, it can be seen that electron transitions from higher energy level to lower energy level is responsible to produce the photon that gives the discrete line on the emissions line spectrum. Hence, by knowing the energy levels involved in the electron transitions, we can calculate the wavelength of the photon produced using the Ribot equation. For instance, electron transitions from energy level n equals to 3 to energy level n equals to 2. By substituting the energy levels into the Ribot equation, the wavelength of the photon can be obtained. Note that in the Ribot equation, n1 is smaller than n2, as 2 is smaller than 3. When substituting into the equation, n1 should be 2 and n2 should be 3. Wavelength calculated for the electron transition should be 6.563 times 10 to the power of negative 7 meter. When converting to nanometer, 656.3 nanometer is obtained. The wavelength calculated is corresponding to the wavelength of the red light and giving the red line on the line spectrum. The same calculations can be performed to determine the wavelength of photon for electron transition from n equals to 4 to n equals to 2. These transitions will produce wavelength corresponding to the green line on the line spectrum. Same calculations for electron transitions n equals to 5 to n equals to 2 to produce the wavelength of blue line. To test your understanding, you can pause the video to perform the calculations for electron transitions from n equals to 6 to n equals to 2. The photon with wavelength of 410.2 nanometer should be obtained. The wavelength is corresponding to the violet line observed in the emissions line spectrum. The following video is another example explaining how line spectrum is being produced from the electron transitions. At ground state, n equals to 1, electron absorb energy and move to higher energy level n equals to 3. At n equals to 3, electron is unstable and will fall back to lower energy level n to 2 by emitting photon of red light wavelength and giving red discrete line on line spectrum. At ground state, electron absorb energy and move to higher energy level n equals to 4. At n equals to 4, electron is unstable and will fall back to lower energy level n equals to 2 by emitting photon of green light wavelength and giving green discrete line on the line spectrum. At ground state, electron absorb energy and move to a higher energy level n equals to 5. At n equals to 5, electron is unstable and will fall back to lower energy level n equals to 2 by emitting photon of blue light wavelength and giving blue discrete line on the line spectrum. At ground state, electron absorb energy and move to higher energy level n equals to 6. At n equals to 6, electron is unstable and will fall back to lower energy level n equals to 2 by emitting photon of violet light wavelength and giving violet discrete line on line spectrum.